Okay, homework 10 demo. So for this homework, you would add the ability or the functionality to write out the games to a file when the application exits, and when the application opens, then you would want to read that file into the manager, recreate the games vector, and then you would have an ongoing true history of all the games played in a computer, right? So then you kind of get the realistic application feel. So again, so when you are writing out the vector of games, you iterate through the vector of games, but each game has a vector of pegs. So then you have to iterate through the vector of pegs, create the output file for the game, and then have the last character be the winner. Doing it this way takes less logic, and you don't have to, when you read it back in, when you read the file back in, you recreate the vector of pegs and then recreate the game. You don't have to determine who won. You set the winner in the constructor for the tic-tac-toe, and that way you use fewer lines of code, okay? So how would this work? Well, everything works the same. You're just adding the ability to write out to file, right? So if we go and look at the header file, it looks something like this. And it's always good practice to use a const string for the file name. And then we have a save games that accepts a reference to unique pointer vector of tic-tac-toe, and then a unique pointer tic-tac-toe is returned from get games. So being that it's the last homework, I will share the code for this one. So one of the gotchas for this one was the save games is easy. Well, kind of, right? So you have to create the out file, output file stream. File name is from the header file. Tic-tac-toe game data, I believe, is the name of the file. So if the file doesn't exist, then C++ creates it, and that happens on the first time it tries to save the games, okay? And also, what's going to be happening every single time the program runs, it'll overwrite the file. So whatever's in memory, that's what it'll write. So it'll read all the games, and if you say it was 3 games and you play 3 more games, so then it'll recreate a new file, but it'll save 6 games. And this was the easiest way to do this. In a real application, we wouldn't do it like that. We would probably, after each game, save the output, okay? So, but I wanted to make this simple enough, but also give you the real life experience of what it is to, how it is to create a program with a file backend, okay? So we open the file. If the file is open, we iterate through the games. So for each game in games, and then recall that each game has a vector of pegs. So then we say for each game in pegs, then go ahead and output the letter, right? So XO space, right? So it'll output regardless, right? If it's an X or no or space. So it does this until it reaches the end of the pegs, and then you go ahead and output the winner without any spaces, okay? And then a new line character, and then we make sure we close the file. This one was pretty much straightforward. Now the get games is a little bit more tricky. So you create the vector of games which you'll rebuild. Then you create the if input file stream in file. You open it. You create a line, and this is for each line that's going to be read from the program, okay? If the file was opened, then we want to iterate with getLine in file line, okay? So in file is in file stream and line, so meaning read each line at a time. So here we have one line, we create a local vector of string pegs, we iterate through line size -1, okay? And what we need to do is we need to create a string. In my case, I say string of ch. We use a constructor, meaning its length of 1. Use the line of I, or the character at I. And after you create the ch, which is the string, then push it into the pegs vector. I do this for each character in pegs, okay? Next, then I go and get the winner by getting the last character in the line that was read, right? So remember, the last character is the winner. So then I say from the line at line size -1, meaning the last character. Get it? Tell C++ save some space for a tic-tac-toe unique pointer. If it's size 9 pegs length, then create a tic-tac-toe 3, use pegs and winner as the arguments. If it's 16, then create a tic-tac-toe instance of 4 and use pegs and winner as the argument, and of course use make unique to create the memory on the heap. Finally, we move the game into our vector. It does this for every game, and then finally it'll close the file and we return the games, okay? If we go into the manager, in the manager you have to create the tic-tac-toe data private variable, and you have to add a constructor that uses tic-tac-toe data, and then you initialize data, the private variable, with the incoming argument, okay? Afterward, you say games equals data.getGames. You iterate through the games. I don't think this code is required because we already. Oh no, oh yeah, update winner count. Yeah, we do have to do this. Sorry, we do have to do this to get the winner count. So we iterate through the games and then we update the winner count. So I think I messed up on the instructions there. So if you're watching this video, then I'm showing you what needs to be done, right? Because we need to update the winner count for the manager, like how many wins, how many losses for X or ties with, call it a tie, okay? And then you would have to add a destructor in the header. So notice we have a destructor. Remember, the destructor runs when the class is removed, right before the class is removed from memory. So there you would say data.saveGames, and they would save all the games into a new file, okay? Also for tic-tac-toe, you would need to add this get pegs, okay? And for manager, you would have to add get, let me see, not manager, but actually you don't have to do it for manager because we are doing it in the constructor. So we go back into the constructor, we have data.saveGames. So the games is in here. Okay, so once you do this, then the app should work. So we can go ahead and execute it. Three or four, 3x1. Let me go ahead and display more of this. 1, 2, 4, 5, 7. Yes, now load 4x, 1, 5, 2, 6, 3, 7, 4, 1, 1. I don't want to play anymore. Where can we find the file? Well, if you copy this path to Windows Explorer, then we can go and find the file, right? So I'm going to copy it just to, and then notice we have this file. We open it, And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have the winner. 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then we have X, right? So we can get the winners. And we come back and we can run our program again. And then we say 3, X goes first. 1, 2, 4, 5, 7. No, I don't want to continue. So X is 2 to 1. And then we can just briefly inspect if it's keeping our history, and it is. We can go back in here and we can open the last file, and notice now we have another record written to file, and that's how the program would run. If you're using the cloud compiler, then you have to use some commands. Let me see if I can access the cloud compiler on this one. So I'm waiting. I've not uploaded the code. Okay, it wants me to sign in. So let me sign into GitHub as myself. Password. Okay. I have to do some configuration. All of them. Move this down here. So if you're running from here, then you should be able to present working directory cd ls. Let me see the replit here. I've not used this one in a while. Okay, so let's try to do a run. Okay, so it's gonna build. It's gonna take a little bit, but I want to run this for the replit users in class. So let's wait for it. %, 94. $98. Should finish here soon. Okay, so let me present working directory ls, go back one, ls. So notice now you have this build directory. So you go cd space build ls, so you're in there. Notice you have an src folder, so then you do cd space src ls, cd space, we want to go into the homework folder, homework ls, cd space 01 variables ls, and that's where I can go and run homework 1 exe, right? So if I had the tic-tac-toe piece working, then I could show you that. Let me see here, ls. So let me go here and let me change this to homework tic-tac-toe, and then let me look at CMake list. It's this name right here. Let me copy it. I put it here. And then I also have to look at the CMake list. So let me unlock tic-tac-toe. Okay, so it's unlocked, so I should be able to run the Riplet and I should compile my tic-tac-toe piece now. Okay, so notice tic-tac-toe compiled. So then let me press on working directory and then build ls src homework tic-tac-toe, and then I can run tic-tac-toe. Let me see. I don't know if this has the updated home assignment. Unfortunately, I've not downloaded the source code to here. Let me see. So let me do a pull. Hopefully it brings it. Pull. It's not pulling it. Pull. Well, anyways, my pull's not working. Sometimes Replit does that, but at least you more or less have an idea of what you would need to do, right? This is how you run your app from the command line. But also in this folder, if you do ls enter, you would see the tic-tac-toe.dat file. You could see it in here, and then you could try to open it. Let me see here. So VI, and notice that it opens it, and then you could do like :quit to exit, and that's how you could see your tic-tac-toe.dat file. I didn't open it because I don't have the source code, and as you saw, it didn't let me download, but hopefully that gives you an idea of what you will need to do to see that in action. Okay, so thank you.